Hi everyone. In the previous topics, we have reviewed the mathematical techniques and also walked you through the computer software skills that is useful in the course of Econ 1210. Starting from topics 8 and 9, we would like to refresh your memory on the economic concepts of this course. But right now, we'll be talking about horizontal and vertical aggregation. This topic is divided into two parts. So one question about perfect competition will be left to part B. So let's start with the review part about the horizontal and vertical interpretation of demand and supply curve first. So here about the interpretation of the demand curve. So what does it mean by the horizontal interpretation of the demand curve? So you're given a particular price and you would like to find a corresponding quantity according to the demand curve. So this is what it means by the horizontal interpretation of the demand curve. So what you are trying to do here is to find the number of units that buyers are willing and able to buy at this particular price. So as you can see, at the price of $4, the corresponding quantity demanded will be 4,000 lobsters. Okay, so this would be the horizontal interpretation of the demand curve. So for a better understanding, for a usual demand relationship, we will have something as follows. When the price increases, the quantity demanded would decrease. And if you add vice versa and ceteris paribus condition, it would be the full picture of the law of demand. So this is what it means. So this is a law of demand. And we also have the vertical interpretation of the demand curve. So what's that? This time you're given a particular quantity and you wish to find the corresponding price according to the demand curve. So this is the vertical interpretation of demand curve. What you're trying to find out here is the maximum price that buyers are willing and able to pay for this particular quantity. So at the quantity of 4,000 lobsters, the corresponding price according to the demand curve is $4, which means that the marginal benefit of the consumer for the 4,000 lobster is $4. So this is how we can find the marginal benefit of the marginal consumer using the vertical interpretation of the demand curve. We also have something similar on the supply side, the horizontal interpretation of the supply curve first. Again, you're given a particular price and you wish to find the corresponding quantity as suggested by the supply curve. So this would be the horizontal interpretation of the supply. So what you are trying to find out is the number of units that producers are willing and able to sell at this particular price. So at the price of $4, the corresponding quantity is 2,000 lobsters. This means that the quantity supplied would be 2,000 lobsters. And we have the law of supply here. For usual supply relationship, we'll have price and quantity supplied to move in the same direction. Okay? When price increases, the quantity supplied will increase. Adding again the vice versa and ceteris paribus condition, then it will be the full picture of the law of supply. Next, about the vertical interpretation of the supply curve. So you're given a particular quantity and you wish to find the corresponding price according to the supply curve. So what you're trying to find out would be the minimum price that suppliers are willing and able to sell at this quantity. So if you put some jargons here, it is simply the marginal cost of producing one additional unit. So relating the graph here, at the quantity of 2,000 lobsters, the corresponding price is $4, which means that the marginal cost of producing the 2,000 lobsters is $4. So this is how we can find out the marginal cost of production using vertical interpretation of the supply curve. The next technique is about horizontal aggregation. So for horizontal aggregation, we are trying to sum up quantities. So when do we like to sum up quantities? For example, if we are going to derive the market demand and supply, then we are summing up quantities. Okay, so the demand of the whole market equals to the demand of the first person plus the demand of the second person plus someone else. Right? on a similar token. The supply of the good equals to supply of the first person, supply of the second person, and supply of someone else. As you can see here, to derive the market demand and supply, we are summing up quantities instead of prices. So it does not make sense if you say that, oh, the price in the market equals to the price paid by you plus the price paid by me plus the price paid by someone else, right? So this is why we sum up quantities. The quantity demanded from you plus the quantity demanded from me plus the quantity demanded from someone else derive the demand curve. The second remark, if individual curves have different y-intercepts, then the market curve would kink. In fact, why does the market curve kink? It is because there's a change in slope in different price ranges. So using the demand curves here as an illustration, when the price is high, then only the blue buyers will be able to buy. So this is why we only incorporate the demand of the blue buyer when the price is above 50. However, when the price is lower than 50, then both the green buyer and the blue buyer are willing and able to buy. So this is why we need to sum up the demand expression for the blue and the green buyer. Since we have different expressions of the market demand curve across different price range, then the market curve would kink. So the takeaway is that if the individual demand curve have different y-intercepts, then the market curve would kink. Similarly for the supply curve. How about vertical aggregation? We are trying to sum up prices for this part. So under what situation we would like to sum up something about prices? For instance, when we are going to derive the marginal social benefit curve, then we are summing up the marginal benefits of individuals, right? Marginal social benefit equals to the marginal benefit of you plus the marginal benefit of me plus marginal benefit of someone else. So we are summing up prices instead of quantities to derive the marginal social benefit curve. And we also have the second remark. If individual MB curves have different x-intercept, then the marginal social benefit curve would kink. Referring to the two diagrams here, suppose I call this as the marginal benefit of John and this one as the marginal benefit of Steve. Okay, so when the quantity of the public good is now low at this level, then both John and Steve is perceiving the good at the positive value. So this is why the marginal social benefit expression should incorporate both the individual benefit of John and Steve when the quantity is low. However, when the quantity is large, let's say at this level, then John no longer perceives the public good with a positive value, only Steve does. So this is why when the quantity is large, then we just need to take into account the individual benefit expression of Steve. As we have different expression of marginal social benefit curve at different quantity ranges, then the marginal social benefit curve would kink. To conclude, if individual MB curves have different x-intercepts, then the marginal social benefit curve would kink. So that's about the recall part of horizontal and vertical aggregation. So move on to the problem sets. The first one is about the supply curve. So question 14 requires you to find out the total quantity supplied from Utopia as a whole at the price of $11. So this requires you to make use of the technique of horizontal interpretation of the supply curve. So how can you do that? Let's derive the market supply curve first. And be aware, because the question gives you P as a subject of the supply curve, we need to do the change of subject using Q as a subject first. Because when we derive the market supply curve, we are performing horizontal aggregation, which is to sum up quantities instead of prices. So this is what I'm trying to do in the first step here. After that, we can start deriving the market supply curve. And the market supply can be written into two different expressions across different price range. Why? Because when the price is above 30, nothing special. both East Utopia and West Utopia are supplying positive units. So this is why we incorporate the individual supply of East Utopia and West Utopia when the price is high enough. However, when the price is lower than 30, in particular between $8 and $30, then only West Utopia is supplying positive units, but not for East Utopia. And this is why when the price is between 8 and 30, we only take into account the individual supply of West Utopia in the market supply curve. Referring to the GeoGebra screenshot here, you can understand the shape of the market supply curve better. When the price is high, then we take the combined expression, the red portion. When the price is low, between 8 and 30, then we take the individual supply curve of the West Utopia as the market supply curve. So the yellow highlighted part would be the market supply curve in this case. It is kink. Okay, so for question 14, to find out the total quantity supply at the price of $11. So nothing special. We just draw a line at the price of 11 and find the corresponding quantity as suggested here. So 4.29 will be the total quantity supplied at this level by the horizontal interpretation of supply curve. How about question 15? If the total quantity supplied from Utopia is 300 kgs, what would be the marginal cost of producing the 300 kg? It would be requiring you to make use of the technique, vertical interpretation of the supply curve. You're given a particular quantity and you wish to find the corresponding price according to the supply curve. So referring to the diagram below here, so at the quantity of 300, the corresponding price as suggested by the market supply curve is $135.75. So this is the marginal cost of producing the 300 unit. So as you can see, we need to identify the correct position of the market supply curve in order to solve this problem. If you only blindly use the combined expression, the red curve at different level of prices, then it would incur an incorrect answer. So that's all for this problem, and we'll move on to the next one. This time, it will be about the demand side, and we are going to find the market equilibrium price and market equilibrium quantity. So to derive the market demand curve, we are performing horizontal aggregation again. However, the question gives you price as a subject, so you need to do the change of subject to express Q in terms of P. The first steps I have put down here. The market demand curve would kink and can be written into two different expressions across different price ranges. Because when the price is lower than 677, then both groups A and B are buying positive units. Then you need to sum up the individual demand of group A and group B buyers. However, when the price is high, higher than 677, then only group B is willing to buy positive units. Then we just put the individual demand expression for group B consumers in the demand curve when the price is high. So referring to the graph here, we can highlight the market demand curve. When the price is low, then the combined expression, the red curve. Whereas when the price is high, we only take into account the individual expression of group B, the blue part. High price, blue part, low price, the red part. So the yellow highlighted portion is the market demand curve in question. Now we are required to find the equilibrium point. So we also put down the market supply curve, which is already directly given. The intersection between the upward sloping supply and the kink yellow demand will give us the equilibrium point. So the equilibrium quantity is 781.88 and market equilibrium price is 651.25. All right, so how about the next question? It is about the vertical aggregation to derive the marginal social benefit curve. So we are given the individual MB curve of Adam and David. And for question 49, first part, it asks you to derive the total marginal benefit curve, which is simply the marginal social benefit curve, right? So how can I do that? Again, we need to check different x-intercept. The x-intercept of Adam's individual MB is 60 divided by 1.5, while the x-intercept of David's individual MB is 40 divided by 5.5. Apparently, 40 divided by 5.5 is a small number, which means that when the quantity is lower than 40 divided by 5.5, then both Adam and David are perceiving the fountain with a positive value. So this is why we need to put the individual MB expression of Adam and David to derive the marginal social benefit curve when the diameter is low, smaller than 40 divided by 5.5. However, when the diameter is larger than 40 divided by 5.5, then David no longer perceives the fountain with a positive value, only Adam does. So this is why we put only the marginal benefit expression of Adam when the diameter is large. To understand the shape of this marginal social benefit curve, we can take a look at the diagram here. When the quantity is lower than 40 divided by 5.5, the combined expression. And when the quantity is large, greater than 40 divided by 5.5, then we just take into account the individual expression of Adam. So the yellow highlighted part is the marginal social benefit in question. So you just map the points A, B, C back into the table given the question, and you are able to solve the 3 points. Okay, so let's move on to question 50 and 51. We are given the marginal cost of producing fountain of diameter D, okay, $32 in question 50 and 32 plus 0.1D in question 51. How can we find out the socially optimal diameter of the fountain? You just need to plot the marginal cost of producing the fountain and find its intersection with the marginal social benefit curve that we have just derived in question 49, and it would give the socially optimal diameter of the fountain. If the marginal cost is 32, okay, in question 50, then we just draw a horizontal line y equals to 32 and to find the intersection with the marginal social benefit curve. So this point will be giving us the solution. The socially optimal diameter is 18.67. How about in question 51, when the marginal cost is 32 plus 0.1D? Nothing special. We just put in this expression into GeoGebra and to find the intersection with the marginal social benefit curve. After that, we have the socially optimal diameter to be 17.5 here. We have explained the techniques of horizontal aggregation and vertical aggregation with examples. So hope this will consolidate your understanding of these two different techniques and don't mix them up in solving the problem. So it will be part B here. We are given the total cost and marginal cost information here, and we are required to derive the short-run supply curve of this industry if there are 50 hotels in the market. So how can I do that? Recall your knowledge in perfect competition. The marginal cost curve is actually the supply curve of the individual firm. So this is the key point that you need to recognize. If you rearrange the marginal cost using small q as a subject, then we have this expression. Okay, so to derive the short-run industry supply curve, we are actually summing up quantities. If there are 50 hotels in the market, then the short-run industry supply will be as follows. The market quantity equals to the quantity produced by firm 1 plus the quantity produced by firm 2 plus a quantity produced by many firms until the quantity produced by the 50th firm. So this is why I perform the change of subject, express Q in terms of P, because we would like to sum up quantities for horizontal aggregation. Note that these 50 firms are actually identical, so we can use the relationship where the market quantity equals to number of firms multiplied by the quantity produced by each individual firm to derive the market supply curve. Okay. So for N, the number of firms, we have 50. And for the quantity produced by each individual firm, it will be according to the individual supply curve or the profit maximization condition. So we have the expression here. So mapping this short industry supply with the form given the question, we will write P as a subject, and we will have A equals to 310 and B equals to 2. And this answers the question here. All right, so that's all for the example questions in the topic of horizontal aggregation and vertical aggregation. Thank you very much for watching this video to consolidate your knowledge for this technique.